Hello and good morning dear students. So welcome back to the online class. So in today's class we'll start with question number 14. Okay, we were doing linear differential equation. Question number 14 is x divided by dx plus y is equals to x log x. Okay, the first thing out here is we have to take x common so that we can make the coefficient of dy by dx 1. So please take x common. So this will be dy by dx plus y by x is equals to x log x on the right hand side. So on the left and right we can cancel x and x so that we get dy by dx plus 1 by x into y is equals to log x, which is a linear differential equation in y with p is equals to 1 by x, q is equals to log x. Okay, so your integrating factor will be e to the power 1 by x dx integration, which is e to the power log x, which is x. Okay, and now its solution will be y into integrating factor is equals to integration q into integrating factor dx plus c. So now we just have to use u into v rule, integration by parts. So yx is equals to L-I-I-L-A-T-E, which comes first? Log, right? So log x integration of x dx minus differentiation of log x. Okay, these things you also know how to do, dx and then plus c, so I'm doing it very quickly. So xy is equals to x square log x by 2, okay, minus differentiation of log x is 1 by x and integration x square by 2, okay, dx, finally it gets cancelled out. So 1 by 2 is a constant, it comes outside. So xy, x square log x. So this integration by parts, you know how to do it, okay, so I don't have to tell you. So 1 by 2 is a constant, and when you integrate x, it will be x square by 2. So right, it will be 1 by 4 x square plus c. So this is going to be your answer. So please pause the video, note it down. The important part out here is to identify LDE, to find integrating factor, and then to integrate this. The rest is very, very simple. Okay, so please pause the video and note it down. Alright, let's proceed with question number 15 part 1. In the question number 15 part 1, the question is dy by dx plus y cot x is equals to 2 sin x. Okay, so no doubt it is LDE because it is in the form of dy by dx plus py is equals to q, where p is a function of x cot x and q is also a function of x. Okay, so with this information we can find integrating factor. Integrating factor will be integration e to the power integration cot x dx. Integration of cot x, I hope you know the formula. Integration of tan x is minus log cos x, and integration of cot x is log sin x. So hence e to the power log, so only sin x. And now is very simple solution. Y into integrating is equals to integration q into integrating dx plus c. Okay, so y sin x is equals to 2 sin square x dx plus c. Now tell me, have you seen this 2 sin square x before in this formula of cos 2x? Remember, cos 2x has 4 formulas: cos square x minus sin square x, 2 cos square x minus 1, third one 1 minus 2 sin square x, and in terms of tan is 1 minus tan square x divided by 1 plus tan square x. I've given this formula before also, so please do brush up all these formulas and put the value for 2 sin square x, which will be 1 minus cos 2x, and then the integration is very simple. You know it already. So pause the video and note it down properly. Okay. Alright, let's proceed with the next question, that is number 16 part 1. So number 16 part 1, the question is tan x divided by dx plus 2y is equals to sec. Okay, first of all you can see the coefficient of dy by dx is not 1. So how will I make it 1? By taking tan x common. So take tan x common. Within the bracket it will be dy by dx plus 2 by tan x into y is equals to sec x. Okay, now what happens to this tan? This tan will come in the right hand side in the denominator. Okay, so here it will be dy by dx plus 2 into 1 by tan means cot, so 2 cot x into y is equals to sec. Now sec means 1 by cos, tan means also sin by cos. So what happens out here is sec 1 by cos, tan and sin by cos. I can cancel cos and cos. So cos x gets cancelled out. Please be out here. So I have only 1 by sin, and 1 by sin means cosec. 1 by sin means cosec. So hence the whole differential equation will again be in the form of linear differential equation with the value for p as 2 into cot x and the value for q as cosec x. So I hope you are clear with this. It is a LDE, right? And now we go to its integrating factor. Its integrating factor is given by e to the power integration p into dx. 2 is a constant, please take it outside. So integration e to the power 2 integration cot x. The integration of cot x is log sin x. I've always told you, if you have to use this formula, the coefficient of log has to be 1, which is not in this case. So use the property. Use the property, take your 2 to the power. So it becomes e log sin x to the power 2. Okay, now the base and the number is same, so hence the value for this will be only sin x whole square, which means sin square x. Okay, so sin square x is our integrating factor. Sin square x is our integrating factor. So if this is the integrating factor, then the solution will be y into integrating factor is equals to integration q into integrating factor dx. Okay, let's proceed now. So therefore this will be as y sine square x is equals to, cosec means 1 by sine. So 1 by sine and square gets cancelled out, so only integration of sine dx plus c. Therefore this will be y into sine square x is equals to minus cos x plus c, so which is going to be your answer. So please pause the video and note it down properly. Alright dear students, so let us start with number 17 part 1. Number 17 part 1 and 17 part 2, half I've done and the last portions you'll do it yourself. Okay, so 17 part 1, it's already in LDE where p is minus 1, q is cos x. So integrating factor will be e to the power minus 1 dx, that is e to the power minus x. So its solution will be given by y into integrating factor is equals to integration q into integrating factor plus c. So here we have to use integration by parts and you can simplify it yourself. Okay, so this you'll do yourself. Please pause the video and note it down. Alright, I hope you have noted down. Now we move to 17 part 2. In 17 part 2, please take x log x common first. So once you take x log x common, then you'll be getting this line. Okay, I hope I can clear this. Alright, so we'll be getting this line. And after that, here what happens is, once you take common, this and this gets cancelled out. So log x and log x gets cancelled out. So therefore I get dy by dx plus y by x log x into y, 1 by x log x into y is equals to 2 by x. So which is our linear differential equation with p is equals to this and q is equals to this. Okay, now comes your integrating factor. So in integrating factor, e to the power integration 1 by x log x dx. So now this integral, okay, 1 by x log x dx, if we substitute p is equals to log x, then you are going to get dp is equals to 1 by x dx. That is, you will be getting 1 by x, dx by x as p. Alright, sorry, dx by x as dp and divided by p. Again you will be getting log p. Again you will be getting log p out here. So e to the power log p. You'll be getting e to the power, let me clear this first, you'll be getting e to the power log p. Okay, and by the way, what was your p? This will be log p, right? This will be log p, and here it will be only p. And what was our p? Our p was log x. Log x. So your integrating factor will be your log x. Integrating factor is going to be a log x. Okay. Please pause the video till here and note it down. And your solution will be y into integrating factor integration q 2 by x into integrating factor dx plus c. And from here again please use integration by parts, ILETE, using this as the first function, and this is x to the power minus 1. We can also write this as 2 into log x into x to the power minus 1 dx plus c. So in this way we can do our integration. Okay, so pause the video and note it down. Alright, so this much for today. Today's assignment will be to complete 17 part 1 part 2 as well as 14 part 1 and 14 part 2 and 15 part 2. So please complete all the sums and submit it by tomorrow. Okay, take care.